Hi, everyone, and welcome to today's NHTSA webinar on Bike-Ped Portal, the National Bicycle and Pedestrian Count Archive. My name is Lisa Patterson, and I will be your moderator for today. I'm the Tech Transfer and Workforce Development Program Manager for TREC, the Transportation Research and Education Center at Portland State University. TREC houses NHTSA, the National Institute for Transportation and Communities. NHTSA is the federally designated National University Transportation Center for Livable Communities and is a Portland State-led partnership with the University of Oregon, Oregon Institute of Technology, University of Utah, University of Arizona, and University of Texas at Arlington. Our webinars are based on original research conducted by faculty, researchers, and students at NHTSA partner universities. The goal of these webinars is to get useful research results into the hands of practitioners, academics, and other stakeholders. All right, our speakers today are Hagedorn and Dr. Sirisha Kothuri from Portland State University. Hagedorn is the interim director of TREC at Portland State University and manages several large research programs, including the National Institute of Transportation and Communities and the Initiative for Bicycle and Pedestrian Innovation, IBPI. Through IBPI, Hal coordinates workshops that help provide training to practicing bicycle pedestrian professionals, and more recently, training university faculty on integrating bicycle and pedestrian topics into their curriculum. Dr. Sirisha Kothuri is a research associate in civil and environmental engineering at Portland State University. Her research interests are in the areas of multimodal traffic operations and signal timing, pedestrian and bicycle counting, and performance measurement and safety. She currently serves as a research co-chair of TRB's Bicycle and Pedestrian Data Subcommittee and is also a member of TRB's Standing Committee on Pedestrians and Traffic Signal Systems. All right, before diving into the webinar, I'd like to let you know about a few upcoming webinars and trainings. On April 26th, Danya Rumor from the University of Utah will present on tools and techniques for teaching collaborative regional planning and enhancing livable and sustainable transportation in gateway and natural amenity regions. And on May 30th, Arlie Atkins from University of Arizona will be presenting lessons from research on planning for walkable, inclusive communities. And in addition, we have our annual Summer Active Transportation workshops that may be of particular interest to our webinar audience today. We host 3 workshops, each with a different focus. The first workshop is a faculty workshop designed to help transportation planning and engineering faculty integrate a holistic approach to bicycle and pedestrian topics in their courses. Our second workshop focuses on bikeway design. Leading practitioners in the field will teach the fundamentals of bikeway design through an intensive week of interactive classroom sessions, field tours, and design exercises. And lastly, our third workshop will offer insights and strategies on active transportation programs and transportation demand management, including a behind-the-scenes peek into Portland's Sunday Parkways, our premier open streets initiative. If you're interested in learning more information, you can visit the link shown here. All right, before I hand it over to Hal and Sirisha, I'd like to give you a brief overview of the webinar. Hal and Sirisha will present for about 40 minutes, and during this time you can submit questions which will be answered at the end of the webinar. We will be recording today's webinar and we'll make it available on our website, but you will also receive the video recording and presentation slides in an email following the webinar in the next day or two. If you are tracking professional development hours, the webinar is eligible for 1 hour of continuing education credit, and instructions on how to redeem the credit will also be included in your post-webinar email. During the presentation, please submit questions for our presenters by using the questions pane on your control panel. We will track the questions and presenters will respond to them at the end of the webinar. If we run out of time, we will send out written responses for any questions left unanswered. And with that, I will hand over the presentation to Hal.
Okay, great. Thanks, Lisa. Hold on a second. I'm getting the presentation up. All right. Thanks again, Lisa, for that introduction. Again, my name is Hagedorn, and thank you for joining this webinar on Bike-Ped Portal. My colleague, Sirisha Kothuri, and I will be spending the next 35 to 40 minutes sharing with you the progress we've made on this project. So here's an outline of what we will be covering today. I know that based on the folks who have signed up for this webinar, we know that we have a variety of folks who are tuning in. Some of you may have more expertise than Sirisha and I with bicycle and pedestrian data. There may be some who are fairly new to the topic, and probably many who are somewhere in between. So we want to make sure that that everyone is starting from a common place of understanding. And so with that in mind, I will talk briefly about why counting bicyclists and pedestrians are important, the types of counts that exist, and the various existing online archives for these data. I will then discuss the initial phase of BikePed Portal the BikePed Portal project, which was creating the online archive. I will also provide an overview of the current phase of the project, which are enhancements to the public portal. And this public portal focuses on visualizing the data in the archive. And then I will hand things off to Sirisha, who will then cover the potential uses for these data and the visualizations. And then she'll talk about some of the next steps for us as far as what we intend to do with BikePed Portal. So why do we need to count bicyclists and pedestrians? And as transportation professionals, whether you're a planner, an engineer, a researcher, or even an advocate, you need accurate bicycle and pedestrian data for a whole variety of reasons. And at the simplest level, you need to know how many people are biking and walking and where they bike and walk in your community. And you need to know that on a daily basis from year to year. And this helps planners and engineers determine and prioritize needs for facilities and to better plan for investments. You need to understand and measure biking and walking patterns in order to compare it to other modes or to design better facilities. And finally, how can you quantify the benefits of active transportation without a more accurate count of bicyclists and pedestrians in your community? There are many, many more reasons why we need to count, and the more we share how we use these data, the more effective we can be in making the case for biking and walking. Simple, right? Well, not so fast. Counting bicyclists and pedestrians, it's not as easy as it sounds, and in spite of many jurisdictions and entities collecting counts, they take many different shapes and forms. So counts can be obtained from surveys at the national, regional, and local levels. Counts happen on a project-by-project basis in the form of intercept surveys. You can get counts from GPS and other physical activity apps such as Strava. You can also use technology such as tubes and cameras to count bicyclists and pedestrians. These technologies can be permanently installed, like the counter installed in the lower right-hand photo. This is a photo of an eco-counter device that was installed on the Hawthorne Bridge. These permanent installations are typically found in locations with consistent and high bicycle and pedestrian volumes. They can consist of short duration counts taken using technologies or volunteers, like in the picture in the lower left. So I don't know if you noticed, but that's a photo of Kristen Nordback, one of the leading researchers in this area, with a handful of transportation faculty from across the country, and she's guiding them through a manual count exercise in Portland. So these counts support, as I mentioned before, the design, planning, and advocacy activities that I talked about in the previous slide. So again, counting is not as simple as it sounds. So what counts? Here's a fairly straightforward count. What do you see here? You have 3 kids on a bike, and let's hope that they all ride over the loop that's in the road. Or if you're observing this count manually, it's pretty easy to determine that there are 3 bicyclists. But how do you count someone who is, let's say, riding a cargo or a high occupancy bicycle? So if this bicyclist were to ride over a loop detector or infrared counting device, how would they be counted? If somebody is counting manually, how would they be counted? Helmet use, would that be easy to denote? What about gender? Or what about this scenario? How many bicyclists are counted in this scenario? Or this scenario? But I think this one takes the cake. This may give you some pause, but it perfectly illustrates the complexity of counting bicyclists. And this is a photo of Emily Finch, who is somewhat of a local bike celebrity here in Portland, and she is riding with 6 kids. right there. And there are actually two separate bikes in the photo. So aside from how data are collected, non-motorized counts differ in the locations in which these counts are taken. So there are two main types, the screen line and intersection counts, and both are useful. Screen line counts help to identify general use trends on a facility. They're used to calculate pedestrian miles of travel or bicyclist miles of travel. And intersection counts are typically used for safety and other operational purposes. So once you've collected these counts, now what? These counts are stored in a variety of ways as Excel spreadsheets. Some agencies store them as PDFs or even as paper files. You can also submit and share your data with the Federal Highway Administration through the Travel Monitoring and Analysis System. Some agencies have developed a local or regional online clearinghouse for their count data, and this allows you to view counts spatially as well as temporally. But it is not easy to access counts in other locations for comparison purposes. And it's not easy to visualize or combine manual and automated counts, as well as intersection and screen line counts. So this is where BikePed portal comes into play. These existing databases have served as an inspiration for BikePed portal. Several years ago, through a research grant from NHTSA, pooled with funds from a handful of agency partners from a number of states, Dr. Kristen Norbeck and a team from PSU set out to develop an online non-motorized transportation data archive. And the concept was to develop a way for bicycle and pedestrian counts to be uploaded, stored in an online archive, and then downloadable by users. The concept of the archive would be that it could store a variety of counts, continuous and from continuous and short duration counts, and the counts could be collected both from automated or manual counters. As I mentioned previously, bicycle and pedestrian counts are collected in a variety of ways, and the biggest challenge is to identify and develop a consistent data format that would apply to a large subset of the data collected. For this project, a lot of the time and effort was devoted to developing a data schema that could handle the diversity of formats for non-motorized counts. And in the end, due to time and resource limitations, the schema that was developed focuses primarily on counts taken using a screen line approach. And the priority was on automated counts, since the format for automated counts are a bit more consistent than what you see from manual counts. And the schema encompasses a variety of metadata that helps to describe the location, the facilities, the detectors, and the direction of travel or flows. And so I'm just going to go through this pretty quickly, but this is a visual representation of a segment area. A segment area includes all transportation-related facilities within the right-of-way, such as sidewalks, motor vehicle lanes, bicycle lanes, and multi-use paths. And this segment area does not include traffic at intersections. And here is what a segment area looks like on a map. For illustrative purposes, I'm showing you an aerial view of the Hawthorne Bridge. And then here's an example of facilities. And again, the database can accommodate and tracks of counts that can be taken on a variety of facilities. Finally, here's an example of flow and detector. And then just to wrap up phase one, in phase one, we were able to create a database that allows users to upload data, view raw count data, and download raw CSV files of counts at 15-minute increments from automated manual counts. We created a script that could easily pull in data counts obtained from eco counters, but otherwise we had what I like to refer to as an army of data wranglers processing the data and then uploading it to the database. So this user interface, this access restricted interface supports a variety of research purposes, which Sirisha will talk about later. And we are in the process of increasing the usability of this interface in order to simplify and automate, to the extent possible, the ability to upload additional data. And we're also planning to modify the database and schema in order to accommodate intersection counts. To date, BikePed portal contains data from 580 detectors, 36 million count records, and 223 million trips from 23 counties across the country. So that was phase one. Phase two focuses on the enhancements to better visualize the data in portal. And this culminated in the development of a beta public portal site. I just have several screenshots that I'm going to go through before I hand it over to Sirisha. So the goal of the public portal was to create a simple and easy to use interface that allows users to explore or view data and compare bicycle and pedestrian counts for locations across the country. You can see the locations with data on a map. You can view data at one or more locations. So it doesn't have to be within your jurisdiction. It can be 2 locations from across the country. And the portal aggregates raw count data by specific timescales. You can quickly identify what data are available, including the type, such as bicycle or pedestrian, manual or automatic, and the scope, such as short-term or long-term at various locations. You can filter the sites by facility and count characteristics. Sirisha will go through a variety of screenshots that will show you some predefined charts and tables that we developed as part of this project. So this here is the map view of the public portal. Here I have a screenshot of zoomed into Portland, Oregon. And you can see, you can quickly identify what data are available, including the type, such as bicycle or pedestrian. The peach colored markers are manual counts, while the green denotes counts for automated counters. Okay. So before I hand the presentation over to Sirisha, I wanted to share one last visualization that's available in the public portal. Here we have a dashboard that gives you a quick accounting of all of the data in the repository. And at a glance, you can see the number of detectors, count records, and trips. The number of counters are plotted by years. The total number of pedestrians and bicyclists counted are summarized by year. And we have some simple charts of mode split and facility type. I need to emphasize that this is a beta version, so we are still trying to optimize and speed up such thing as some of the loading of the data and then working out other kinks in the system. So with that, I will hand it over to Sirisha to talk more in depth about the uses of the data from the public portal as well as the access restricted interface.
Thanks, Hao. Hopefully everybody can hear me okay. So good morning and good afternoon to everyone. Now that we have access to all the count data, let's go ahead and see what we can use this for. Okay, I guess I'm not able to advance the slides.
Sorry, Sirisha, I'm trying to hand the mouse over to you.
Okay.
Hold on tight. Okay, try it now.
Okay, there we go. So I'm going to spend the next few minutes talking about some of the potential uses for the count data, and then I'll go over some of the other parallel efforts that we have going on right here at PSU to enhance the BikePed portal, and then I'll talk about the next phase, or phase 3. And then after that, we will be happy to take any questions that you may have. And as Lisa mentioned, please go ahead and enter your questions in the chat pod, and we will answer them at the very end. So when we think about uses for the count data, the first thing that often comes to mind is facility usage. How many people are using the facility at any given point in time? We can use this information to support planning efforts with data and visualizations. And also at locations where there are no existing facilities, if we have count data, we can then show the stakeholders what the demand is at that location and make the case for installing bicycle and pedestrian facilities. This data can also be used to study travel patterns. So we can look at things like, have counts increased or decreased over time? How do they vary over the year, over a month, over a week? How do they vary within a day by time of day patterns? We can also use the data to compare patterns across locations, both within a region, but also across regions. So typically, if you belong to an agency, you just have access to your own count data from your counters. But what if we wanted to figure out how your count data compares to other maybe trails or other locations within the same city where the counters are managed by someone else? So that's where BikePed portal comes in. The power of BikePed portal is that it not only contains data from your agency, but we do have data from different locations around the country. And so this makes it very easy to perform those comparisons. Another use of the data is to detect equipment malfunctions. One way to do this is to see if there are any spikes in the data, which can represent outliers. Or we could also quickly look and see if there are any gaps or missing data for long periods of time. That could indicate that there is something going on with the equipment or something going on with the transmittal process. Another use of the data is to identify trends. So if there are specific improvements in infrastructure, having access to the count data can help identify the impacts by performing a before and after comparison. You could also study the impacts on a specific facility because of construction or opening of another facility. So over the next few slides, I'm going to go over some of these uses that I've talked about. And these are just a few. Of course, there are many, many other uses that you could use this count data for. So as Hao mentioned, we could get the facility demand using this explore feature on the website. We could either type the name of the location that we want to get the facility demand for on the box on the top left-hand corner, or we could use our cursor to zoom into the location and click on that specific detector and then go ahead and plot that data. So once we do that, we get a plot of all the data that exists at a particular location. This is the Hawthorne Bridge again for illustrative purposes. And the Hawthorne Bridge, for those of you that are unfamiliar with Portland, is a major commute route connecting Southeast Portland to downtown Portland. Here we see the data from 2009 to 2018. And this plot here will show you all the data that exists at the location, which includes the automated counts as well as the manual counts. Suppose you just wanted to display just the automated counts, you could click on the labels at the bottom of the plot and turn off the manual counts that you don't want displayed. And if you put your cursor on any one of the bars here, there's a screen or text box that pops up that will give you the demand on that facility. We could also drill down a bit further and look at monthly patterns. So this chart here is for showing the counts from a loop detector at Northwest Lovejoy Street and Northwest 9th Avenue, again in Portland. And here we see that the monthly pattern of counts, and that the counts in the summer months are higher than the counts in the other months of the year. We could continue to drill down and look at weekly aggregates. And here we could perform analysis such as how do the counts in the current week compare to those in the previous week? How do the counts in the third week of August compare to the counts in, say, the third week of August from last year? Continuing to drill down further, we can look at daily counts. So this chart here shows the daily patterns for the same location. The daily patterns are important because they can be really useful in determining if the route primarily has utilitarian traffic, recreational traffic, or both. Here we see in this current plot that certain days, which are weekdays, have higher counts than the weekends, indicating a commuter pattern. We could also use these daily counts to estimate WWI, or the weekend weekday index that was proposed by Miranda Moreno. The weekend weekday index is the ratio of the volume of a weekend day count to a weekday count. And so low values of WWI indicate that the pattern is primarily utilitarian. And finally, we can go to the hourly count. And this is the lowest aggregation that you will see on the Explore page. And the hourly counts are important because we can look at time of day patterns. These are also useful in calculating AMI, which is another index that is helpful in defining the travel pattern of your data. The AMI is a ratio of the volume in the morning or AM peak hour to the noon hour. And so high values of the AMI, again, would indicate that you have a utilitarian pattern at your site. These travel patterns are important because they are particularly useful for developing factor groups, which are useful for expanding your short duration counts into annual average estimates of traffic. Another thing that we could do using the site is to compare patterns across facilities and across regions. In this plot here, we have compared the bike counts on Hawthorne Bridge versus bike counts on Key Bridge in Arlington, Virginia. We could easily see the difference in counts between the two facilities. The same comparison could also be done across facilities in the same region. So the next plot here shows the comparison of bicycle counts again between the Hawthorne Bridge in Portland and Tilikum Crossing, which is another bridge in Portland that contains only non-motorized traffic and transit. Ensuring that the equipment is calibrated and functioning accurately is critical whenever you want to perform some sort of data analysis and you want to ensure that the quality of data is good. Oftentimes, equipment is just calibrated at the time of install, but not thereafter because of the lack of resources. One way that we could help to identify equipment malfunctions is to check the data in BikePed portal. And we can do this by looking at the data availability on the right. This feature is accessible when you sign up, get an account to access BikePed portal, and you can go to the download page on the left and click on a particular flow detector. This is again for the Hawthorne Bridge, and here we see that initially there was no data, and then there was some data, and then it gets into a consistent pattern. So with the data availability chart, what we're looking for is gaps in the data. And again, those gaps could indicate that there is either a problem with the equipment or there is some issue with how the data is being transmitted into the archive. Another way to check if the equipment is functioning correctly is to see if there are any outliers present in the data. This is again for the Hawthorne Bridge, and here we see that in general, the counts are between 0 and 1,000 bicycles, but suddenly we see this spike in the data. And if we dig in a bit further, we see that this happened on August 9th, 2015. And so we can then go back and dig into the data to see whether this is an invalid data point or is this valid. So did this high count actually happen? In this case, this is a valid data point because there was a cycling event called Bridge Pedal in Portland that day, where the bridges are close to vehicular traffic for a few hours and are just available to cyclists and pedestrians. And so the high counts here represent counts from that event. This is a plot from the Key Bridge in Arlington, Virginia. And here we are looking at counts of pedestrians over time. So in general, the counts are fairly constant. But suddenly, again, in July of 2016, we see this big spike. And by big, we are talking several orders of magnitude. So the high count in July was close to 200,000 pedestrians, which was a big difference compared to the other counts. So we went back and checked with the agency, and David Patton at Arlington County was kind enough to do some digging for us, and we discovered that one of the counters on the bridge was malfunctioning at that time. So it's really important, again, to have some data quality checks before you use the data. Lastly, we can also compare trends over time. This is a plot again of the Hawthorne Bridge, and in 2014, the average counts on the Hawthorne Bridge were about 200,000 cyclists over the entire month in both directions. But in 2015, we see a drop in the numbers of cyclists. And to determine why this happened, we know that the Tilikum crossing opened in September of 2015. So we clearly can see the effect of the new facility. And so having access to data from multiple locations can help us answer two questions. One, what is the facility usage on this Tilikum crossing bridge? And two, having access to the historical data on the Hawthorne Bridge, we can also estimate how many riders were diverting from the Hawthorne Bridge to the new facility. So to summarize, the power of BikePed portal is that it can hold all your count locations in one place. So we can have manual counts, continuous counts, and short duration counts. And by short duration counts, we are referring to those automated counts, which are for a shorter duration. And as Hao mentioned, currently we can support screen line count, but in the future, our goal is to also adapt the schema to take in intersection counts. So we can use those counts as well for safety and other analyses. So I just want to take the next couple of minutes to talk about some of the parallel efforts that are going on. One of the research projects that we have on right now that's funded by the Oregon Department of Transportation is to implement some QA/QC checks on the data. We saw the need for this because, as you all know, walk and bike count data have not been consistently recorded, stored, or analyzed. And so the checks for these outliers or erroneous data are lacking, or they're still evolving in many cases. So our goal here is to develop some basic checks that could be implemented into the database. And the checks that we are considering at the very beginning are to flag the data for repeated zero values. And these are values that would occur in times other than at night. We also want to implement a check for appropriate hourly caps based on expected volume. So this check would flag any unexpectedly high or low counts. And so for the example that I showed with the key bridge, this check would flag that data. We also want to try and flag the instances where the AM and PM data are inverted. And this is a higher problem with manual data than the automated data. But it could happen with the automated data as well. So looking at the travel patterns, and again, if you see that you are getting a higher count in the evening when you don't expect it, that's a flag. So our goal here is to not delete any data, but to flag this data and let the user decide whether they want to use this data for their analysis. So the flags that we are considering initially are flagging the data as normal, abnormal but valid, invalid, and unable to determine validity. Another effort that we have going on right now is this project that's funded by the FHWA, Federal Highway Administration, and that project is dealing with automating some scripts to reformat the BikePed data that we have to the TMAS format, so it can be uploaded to TMAS. For those of you that are unfamiliar with TMAS, it is the federal database that holds all counts. And so currently, we have mapped out the common fields between the BikePed portal schema and the TMAS schema, and then we are working on developing some scripts so that we could provide this functionality to users if they need to upload this data to TMAS. And looking ahead to phase 3, this is something that I'm really excited about. And so we have developed a tool that will allow us to take the short duration count data and some continuous count data and develop factors to expand the short duration count data into an annual average estimate. So this tool was developed as part of a research project for the FHWA that was led by Krista Norbach. And the phase 3 goal is to integrate this tool into BikePed portal. So we want to allow the capability of if an user inputs the short duration count data and continuous count data and selects the flow detectors and the date ranges for the analysis period, then the website should be able to give you an estimate for AADT. We think that this would be a very useful functionality and feature to have. So before I wrap it up, I just wanted to point out a couple resources that might be useful. The first link here is a paper in the Transportation Research Record Journal that talks about the process and the steps taken to create this archive. So it includes details on the schema and other important things. The second link here is the final report that was submitted to NHTSA. And this report includes the steps that a user must take to upload the data to BikePed portal. So it walks you through the metadata creation. So kind of what Hal was talking about with the segment area, setting up the facilities and the flows and the flow detectors. The third paper here, and unfortunately we don't have a link yet, but this is a paper that we just submitted to TRB, and it is using the data from BikePed portal to provide some guidance for when agencies are using manual counts. That is, what are the best times to count, how long to count, and what days are best to count for reducing your error when estimating the annual average estimates from those short duration counts. So with that, I'd like to thank all our partners and also Krista for having the vision to make this possible. And we'll be happy to take any questions that you may have. I also wanted to show you the address where you can go explore the archive and the dashboard and some of the features that Hao talked about earlier. So the address is bikeped.trec.pdx.edu, and as Hao mentioned, it is a beta version. We do have some kinks that we have to work out, and it may be slow at certain times, but we are working to improve the functionality and the visualizations. And if you do have any feedback for us, we would welcome it. Thank you.
Great. Thank you, Hal and Sirisha. Really exciting work that you guys are doing. For those of you viewing the webinar, please feel free to continue to submit your questions, but it does look like we have a number of questions from the audience already, so I'll go ahead and get started. There's some questions going back to the data in the BikePed portal, so I think I'll start there. James Wagner asks, will you include information of real-time billboard counters?
So I will start, and then Sirisha, jump in if you have anything to add. When you mean by real-time billboard counters, I'm going to interpret it as that physical counter where you can see the number of bicyclists riding by, and we actually already include the raw counts in the database. So if that's what you mean, then that is included. We don't do any data cleaning at this time of those raw counts.
Okay, great. We have such high bicycle rates with many bicycles riding side by side that tube counters undercount. What affordable tech is available to accurately count bicycles traveling at high volumes?
So Chris and I had worked on this research project for the Oregon Department of Transportation, and we can send out the link earlier, where we evaluated a number of tube counters, both in bicycle-only environments as well as on a roadway. And while it is true that the tube counters do undercount in some cases, there are some counters and equipment out there that are quite accurate. So I would encourage you to check that report out. And if, for instance, the tube counter is undercounting at a consistent rate, for example, you could always develop correction factors to adjust the data.
Right, and Sirisha, would you also suggest going out and doing some spot manual counts also to verify sort of the accuracy of the tube counts as well?
Absolutely, absolutely. And I think we have to do that validation on an ongoing basis to make sure that the counts that we are getting are accurate.
Okay, great. And then we have a couple questions about some really specific data questions. Sirisha, you had mentioned there's a way to flag data to once it's been determined if there's any malfunctioning counters. What about flagging imputed data? Is there a way to show that data's been, does it show in portal that it's been verified or not?
So currently at this time, with the eco counter data, we are grabbing the raw data from the API. So it has not been adjusted in any shape or form as far as we are aware of. So with the manual counts and the other counts, there is no way for us to know whether the data has been imputed or not unless the user who's uploading the data tells us. Yeah.
Okay. And can you give more information on what types of models of counters that can be uploaded into the portal, and also what kind of data file formats are accepted?
So currently, we have developed a script that can automatically pull in eco counter data. But within the database, we do have other types of counters. For example, the counts that we receive from Metro, the Metropolitan Planning Organization here in Portland. They use traffics counters to collect their data, and we have manually uploaded the data, those data into BikePed portal. However, moving forward, one of the strategies that we may put in place is to provide a data format to agencies and others who want to add data to BikePed portal. And then we're also in the process of determining what formats are the most consistent so we can develop a script to pull in those data. So again, those are sort of the future steps that we envision in order to handle all of these other data formats that exist. But consistency, I think, is the key, and it's the biggest challenge we have.
Right, and I just wanted to add on that, as Hao said, we are able to take the eco counter data in currently, and so if you're interested in sharing that data with us, we do have you have to give us permission, and you have to talk to eco counter and make sure that they're aware that you've given us permission to access that data. But there are, as Hao said, other forms of data that we're hopeful that we can develop some automated process once we've identified all the different counters and count equipment types that there are. But the easiest way right now is if there is an API that we could pull the data off from.
Okay, great. David Patton has a question. I know that accurately handling the time change with daylight savings and standard time has been a challenge. Can you discuss how you plan to address that?
So David has left, so do we have to discuss that? No, this is an ongoing issue that we are aware of, and part of the issue is that once we feel like we've developed an approach for handling daylight savings time, some of the formats that we get in changes. And so right now, we know it's a known issue. We're trying to figure out how to best address it. But I think it's a larger discussion that we are happy to have with David off the webinar.
Great. A data collection question about pedestrian counts where facilities are separated, for example, separated to a bikeway adjacent to a sidewalk. How is that pedestrian counts data collected?
So collecting pedestrian counts is very, very challenging, and also doing it accurately is a huge challenge. But there are some equipment out there that are able to collect pedestrian counts. One of the ones that I'm aware of is the infrared counters, and so they are able to detect any warm bodies that pass in front of them. And so if you are able to pair the infrared counter with either a loop detector or a tube counter, then you could subtract the bicycle counts from those total infrared counts to get the pedestrian counts. Of course, if you just have pedestrians on that separated facility, then you could just use the infrared counts as your pedestrian counts.
Okay, great. Thanks, Sirisha. You had mentioned the short duration counts and working to get annual estimates from those count stations. What kind of control will agencies engaged in data collection have over this process? For example, definition of factor groups once it's in the BikePed portal.
That is a good question, and we are still working through that process to determine that. So I don't have a firm answer right now, but stay tuned. And if that's something that you're interested in, please send us an email, and we'll keep you in the loop as we work through that process.
All right, great. Are there plans or interest to expand the count data to include some level of origin destination analysis?
So we have lots of ideas for where to take BikePed portal, and you can get some of the origin destination data from Strava or from some of the apps, the physical activity apps. We have talked about perhaps at some point looking at how that can be used and added to portal, but we haven't figured that out yet. So there is interest, but not concrete plans at the moment.
Okay, great. Is there a way to incorporate weather data in the viewer?
So yes, weather data are available through the National Weather Service, and with other traffic archives, weather has been easily integrated into various archives. You know, a good example is looking at the Delaware Valley Regional Planning DVR-PC. They have weather data included, and so that is something that we could add, and we've talked about that. It's just a matter of prioritizing how to expand the archive.
Okay, great. And this one may have been answered, but maybe you could elaborate. Do you have a way to validate manual count data, or are you working on a way to do so?
So we're hopeful that some of the checks that we are investigating, although those are primarily for the automated counts, we're hopeful that some of that knowledge could be used for the manual count data. But obviously, since we see snapshot in time, it's going to be very challenging to do any sort of analysis. So for example, just see 2-hour counts without any knowledge of the travel patterns or the underlying distribution. It's going to be a challenge, but we're hopeful that maybe there'll be some research that looks into it soon, and then we could use any of the methods that are developed in the research to look at that.
Mm-hmm. Okay, great. Are there plans to add more information on what was used to perform the count? For example, tubes, loops, etc. It may help users understand potential sources of error in the counts.
Currently, we do collect that information. It's not apparent in the Explore data, but for each detector, we do collect information on what type of detector, the make, the model, if it's a manual or not. And that is a good point. You know, that can be used, and it should eventually be used to figure out what the error is or what the potential sources of error are.
Okay, great. This is a question about the script for the eco counter counts. How does the script handle portable counts in regards to location? For example, would be moving a counter twice in a month, the location data is only representative of its current location.
Yeah, so this is one of the things that Krista Nordbeck really had the foresight of, because of all of her work in collecting bicycle and pedestrian counts. So the database is designed for each data flow. In the graphs that Sirisha showed, you will notice that there are a variety of colors demonstrating or kind of showing you which flow of information was collected. And so that's because for each point of data, we know what detector collected that data and what direction and other metadata that's associated. So right now, the database can accommodate the movement of detectors and know which detectors are collecting data at which location. And so in the future, you could, again, use that to help to develop adjustment factors for various detectors that may be undercounting or overcounting. That could be a future direction. We don't have that capability currently programmed into the system.
Okay, great. So it looks like we have time just for one more question, and then perhaps, Hal and Sirisha, you could talk about next steps if people are interested in becoming a user. There are specific questions about if it's available to Canadian users and if you're actively recruiting participation from municipalities. But I'll end it with this question. Are there plans to integrate Strava data or other user-generated data from fitness apps into the portal?
Sirisha, do you want to take that?
Sure. I think you already addressed it, how that right now we have just screen line counts, and it was a huge challenge to get this database to up where it is now. But yes, I think all those data sets are important, and we should consider including them in the future. But right now, I think our next goal should be to improve the visualizations and add more data into the archive and include intersection count. But yeah, I think that's something that we will be considering in the future in terms of expansion.
So, Lisa, I just wanted to add, yes, BikePed Portal is available to Canadian users. You can actually see it on the map. I don't see any reasons why you shouldn't be included. So, yes, that shouldn't be a problem. And then the other piece that you had mentioned is, are we currently actively recruiting participation from more municipalities? We'd love to have more municipalities participate and add data to BikePed Portal. Right now, we're sort of pausing that for the next few months as we make some improvements to the database, and we're hoping that come June, we will be actively recruiting at that point. But until then, you are welcome to go to the website, explore the data that we have, and send us any comments or suggestions on how we can improve the usability of Portal for you as well as other entities.
Great. Well, thank you so much, Hao and Sirisha. This concludes our webinar. Thank you for joining us today, and you can view our other professional development offerings at nitsi.trec.pdx.edu.
Thank you.
Thank you.